Hey everyone, Teacher Chang here, and today we're going to go ahead and take a look at a piecewise linear function that might also be an absolute value function. So our goal is to be able to recognize when that piecewise function is going to be an absolute value function. Let's start off by taking a look at this first scenario. Here we have Michelle. Michelle likes riding her bike to and from her favorite lake on Wednesdays. She created the following graph to represent the distance she is away from the lake while biking. So this is the situation here. Right now she is at home and she's this many miles away from the lake. So she's 6 miles away from the lake. And then she starts to travel towards the lake at a constant speed, and then when she hits that lake, when she turns around and she bikes back home at that same exact rate of speed. So what we're going to do is we're going to go ahead and write our function as a piecewise function. So right over here, it's asking us to write it as a piecewise function, and when we write it as a piecewise function, we're going to use our point slope form. Now, the other thing that they asked us to do is to take our two pieces and use a shared point at 3, 0. So we could see that we have two pieces in this function, and with the two pieces, they're sharing this point right here at 3, 0. So what we're going to do is we're going to start off by writing out our point slope form. What does our point slope form look like? Well, our point slope form has that format of y is equal to m times x minus x1 plus y1, where m is our slope and our x1 and our y1 is our point. So in this particular case, our x1 is 3 and y1 is 0. Now what we're going to do is we're going to write it in terms of a function. So we're going to use f of x to show it's a function. And then we're going to write out our two pieces. So our first piece, we're going to take a look at the one on the left here. And the one on the left is this side right over here. And what we want to do is we want to figure out, okay, well, what is our slope? Well, our slope is rise over run, which means you just pick any 2 points on that line in which you can read the ordered pair. And we could take a look at the rise. The rise is down 2 and the run is 1. So we had to go down 2 and over 1 to get to the next point. So our slope is negative 2 over 1, which can be simplified to negative 2. So I'm going to put that in place for m. So that's negative 2. And then I'm going to keep my parentheses and then the x minus. And then we have our x1, which is 3. That's our shared point here. So that's 3. We'll close up the parentheses. And the y1 is 0. And that's also coming from that shared point. So that means plus 0. Now, we technically don't need to write in that 0. I'm just going to place it in there just so that you know where that 0 goes, or it's supposed to go. Okay, the next thing that we need is an interval for that particular piece. Now that interval, if we take a look, we're looking at our x values. So the interval is from 0 to 3. So it's going from 0 to 3. That's where this entire piece is located. So what we're going to do is we're going to write down that our x values are between 0 and 3. Now we're going to throw in some inequalities here, and because it is on 0 and it is on 3, we are going to put in those equal signs. Now we're going to go ahead and take a look at the second piece, and the second piece we're going to go ahead and do in blue. So we can see that the second piece right over here looks like that. So what we're going to do the same thing. We're going to first find out what is our slope. And again, you can pick any 2 points on that piece, and we can look for our rise and our run. So I'm going to go up 2 and then over 1 to get to that next point. So that means my slope, rise over run, rise 2 and run 1. So we can simplify that to 2. So our slope is 2. And then we're going to go ahead and keep that same point, that same shared point. So that means x minus, and then again, x1 is 3. Then I'll go ahead and close up the parentheses. And that y1, again, is 0. So I'm going to go ahead and put in that 0. But when we go ahead and simplify this, we don't need that 0. All right, I'm going to go ahead and put in my comma. And then I'm going to take a look at the interval for that second piece. Well, that interval for the second piece is from 3 to 6. So she biked all the way up to 6 hours. So that interval is when x is between 3 and 6. Now remember, that 3 has already been used from our first piece. So with that in mind, we cannot make it equal to it because we've already used it in that first interval. And then the second interval, we're just going to put in that less than sign. The 6 is going to be less than or equal to because it does land on our 6. So this is what our piecewise function looks like in terms of this particular graph. So here's our piecewise function. Now this piecewise function happens to be an absolute value function. So we're going to be able to recognize when we have that absolute value function if it meets certain criteria. So let's go ahead and take a look at these criteria that we have here. So when do we have that absolute value? So this is characteristics that you want to look for when we're dealing with an absolute value. All right, the first thing, I told you that this is an absolute value function. The first thing that we should be able to recognize is that they have a shared point. And that shared point is our vertex at 3, 0. So in this case, it's our x1 and our y1, which is 3, 0 in this particular problem. Now, our second characteristic that we need to look for is that the slopes are very, very similar. The slopes happen to be positive and negative m. If we take a look at our slopes, we have a -2 and a +2. So if they happen to have the same value, but one's a positive and one's a negative, well then that's going to be an absolute value function. So it's going to be a characteristic of our absolute value function. And then the third characteristic that we see here is the shape of our graph. And the shape of our graph is in the form of a V. So it's in a V shape. Okay, so it's a V-shaped graph. It has a shared point of x1 and y1, and it has that slope of plus or minus m. Now, if we take a look at it in terms of our point slope form, if I go ahead and write out that point slope form again, it looks like this. So point slope, we stated earlier, is y is equal to m times x minus x1 plus y1. And there's a reason why we wrote it in that point slope form as opposed to a slope intercept form. And the reason why is because, well, if we go ahead and take a look at how we write out our absolute value is very similar. So the absolute value is going to look like this. It's y is equal to, and I'm going to take that slope and put it on the outside. The parentheses becomes my absolute value symbols, and then we have our x minus x1, and then we have our y1. So very, very similar. But that's not the standard form of how we write out our absolute value function. Our absolute value function in standard form is actually very similar to the vertex form of a quadratic. So let me go ahead and write out the standard form. So the standard form for absolute value is going to be y is equal to, instead of m, we're going to place that with an a, x minus, instead of x1, we're going to replace that with an h, and then we have our y1, which is going to be replaced with a k. So this is the standard form of our absolute value. So we can recognize, let's go ahead and highlight some things here. The m value is just like our a value. And our h and our k, well, that's our x1 and our y1. Now notice when I highlighted that h, I did not include that minus sign because that minus sign just means it's going to be the opposite of what it says in that equation or in that point. So I'll tell you what I mean when we take a look at another example. But this is the format that you want to recognize and you want to memorize. The standard form of an absolute value function looks like this. Y is equal to a times x minus h inside parentheses plus k, where a is just like your slope and h and k is your x1 and your y1, which is your vertex. So let's go ahead and take a look at a few more examples and make sure that we understand how to write out our absolute value function and our piecewise function. Okay, so here we have another example. We're going to write out our absolute value function and our piecewise function. Let's start off by writing out the piecewise function because that's what most of us are able to do at first at this point. So let's go ahead and take a look at that piecewise function. And we're going to start off by recognizing our point slope form. Remember, the point slope form is y is equal to m times x minus x1 plus y1. All right, and in this particular case, we're going to look for that shared point, which is located right over here. That shared point is at 1, 2, and that's our x1 and our y1. And then we go ahead and write it all in by looking for our slopes and writing it into our function here. So f of x is equal to, and we got two pieces here. Again, I'll start off the first one in green, and that's this side over here. And I do need to go ahead and take note here that these graphs are missing arrows. So I'm going to place arrows in all of these graphs. So all of our graphs are missing some arrows here. All right, so let's go ahead and keep those arrows in there. Let's look at that first piece on the left. And we could see that the slope of this particular graph is -1 because we're going down 1 and over 1. So the slope in this particular graph is -1. So I'm going to go ahead and write down -1 or just a negative sign if you want. And we could go ahead and put in our parentheses x minus x1. Well, x1 is our point, our shared point, which is 1. And then we have our plus y1, which in this case is 2. So we're going to do plus 2. Then we need to write in the interval. Well, where is that piece located in terms of x? So the piece is located between, from in negative infinity, because it goes on forever to the left, to 1. So it's from that shared point, and it's going forever towards the left. So that means it's everything to the left of 1, which means x is less than or equal to 1. So left means less. So L and L. So left for L for left, L for less. All right, so let's take a look at the second piece here. If we take a look at the second piece, that's this side over here, we're going to do the same thing, and we're going to look for that slope, and that slope has a slope of 1 over 1, or 1. So our slope is 1. You can put that 1 in there, and when we actually write it out, you technically don't need it. And then we have our x minus x1 is still 1, plus y1, which is still 2. So let's go ahead and put in that 2 here. Okay, very similar. Now, the interval for this piece is everything to the right of 1. In terms of our x value, it's everything to the right of 1. Now, since we already included that 1 in the previous one, we're not going to include it in this interval here. But since it's to the right, it is now greater than 1. So there's our piecewise function. All right, so now let's go ahead and rewrite it in terms of an absolute value. Now remember, the standard form of our absolute value is y is equal to a times x minus h in absolute values plus k. And again, let's remember that the a value is like our slope. The h and the k is like our x1 and our y1. Okay, so let's go ahead and plug in what we know, and then we have our absolute value. So let's write it out. So we have y, or f of x, we'll write it in terms of a function, is equal to our slope. Well, our slope, remember, we have two of them. We have one negative and one positive. So we have positive and minus, or positive and negative 1. We're just going to write down 1. And then we have our absolute value of x minus h. Well, h is our 1, okay, and that's our x1. Plus k, which is our y1, which is 2. So this is what our absolute value function looks like for this particular graph. Remember, it has the 3 characteristics. It has that shared point at 1, 2. It has that plus or minus slope at 1, so plus or minus 1. And it has that V shape. So we have that absolute value function. Let's try another one here. So here we have pretty much the same thing. We recognize that this is an absolute value function because it has that shared point, and that shared point is located at 0, 2 this time. And then we have our slopes. If we take a look at the one on the left, well, the slope is down 1 and over 1, so that's -1. And then on the right, we have a slope of up 1 and over 1, so that means the slope is 1. So here we have that same slope, it's just 1 is positive and 1 is negative, so plus or minus 1. And then we have that V shape. So since we have that V shape, we know that this is going to be an absolute value function. Now remember, there are supposed to be arrows here, which was left off. All right, so now that we know it's an absolute value function, this time let's go ahead and write out the absolute value function first. So I'm going to write out that rule again. Y is equal to a times x minus h plus k. And remember, the x minus h is inside our absolute values. So if I were to write this out, I'm going to write that out in terms of a function, f of x, and I'm going to put in the things that we're always going to have. We're going to have the absolute value signs. We're always going to have that x minus. So in this particular case, the a value is going to be our shared slope. So I'm going to go ahead and use that a value right over here as our shared slope. So that's 1. And I'm always going to take the positive. And then we have our x1 and our y1. So our x1 is 0 and our y1 is 2. And that's going to be our h and our k. So here we have the absolute value of 1, or 1 times the absolute value of x minus 0 plus 2. Now, if we were to simplify this, because your teacher will probably ask you to simplify your functions, we just need to solve this really quickly. So if I wrote this out as f of x, and this is still our absolute value, we're going to treat the absolute value like parentheses. So x minus 0 is x. The absolute value of x is still just the absolute value of x times 1. So that's still absolute value of x. And then we have that plus 2 on the outside. So this is what it looks like in simplest form. Okay, so here's our absolute value function. All right, to write out our piecewise function, it's, again, very similar to our absolute. So here we have f of x. We have 2 pieces, and the first piece is this side over here in green. Okay, so I just highlighted that. And we notice that it has that negative slope. I forgot the negative sign here, so let me go ahead and fix that. Let's put in that negative sign. Okay, so we have that negative slope, so I'm going to write down -1. And then we have our x minus x1, so that means x minus 0. And we'll go ahead and close up the parentheses. And then the y1 is 2. And again, compare that with our original absolute value. It looks pretty much the same thing. So now we just need to write out the interval. Now the interval, again, we're taking a look at the x values, is everything towards the left of 0. So that means x is less than or equal to 0. Now to write out the other side, we're going to go ahead and take a look at this other side here. On the right, we can see that the slope is the positive 1. So I'm going to put in the positive 1. And then we have our same shared point. So x minus 0. And then we have our y1, which is 2. Okay, so now we need to take a look at the interval for this particular piece. And the interval is also starting at 0, and it's going to the right forever in terms of our x values. So that means x is going to be greater than 0. And I didn't say equal to because we already used that equal sign in the previous interval. Okay? All right, let's try another one over here. And this one's very similar to that previous one, yet slightly different. Again, let's write out the point slope form and the absolute value function. So the absolute value function, once again, I'm going to write it over here. Y is equal to a times the absolute value of x minus h plus k. So we are looking for that shared point. That shared point is right over here. We know it's an absolute value because it has a shared point. The slope happens to be -1 on the left and a +1 on the right. So we see that plus or minus slope. So we have our slope of plus or minus 1. So that's a big clue that we have an absolute value. And on top of that, we have our V shape here. So we got that V shape, which tells us it's an absolute. Okay, so we know we have an absolute value function, which means we could go ahead and put everything into that format. So f of x, in terms of a function, our a value is just like our slope. So this right here is our a. So I'm going to plug that in, except I'm just going to write down 1. I'm not putting in plus or minus. I'm just putting in 1. And then we have our x minus h. And remember, our h and our k is coming from our shared point. And our shared point is located at -3, 0. In point slope form, it's our x1 and our y1. But in absolute value, in terms of standard form, that's our h and our k. So that means it's x minus 3. Well, or x minus a -3. So minus a negative is a positive. So here we get that positive 3. And then we have our k, and our k value is 0. So I'm just going to throw in that 0, but in terms of standard form, I would ignore that 0. And really, if we simplified this, the simplified version is f of x is just the absolute value of x plus 3. And the reason why, again, if you actually worked it out, well, x plus 3 times 1 is just x plus 3. We keep it in that absolute value. And plus 0, well, that doesn't change anything. So we're going to leave it like this. All right, the piecewise function, same thing. Looks very similar. We have two pieces here. The first piece will be on the left. So I'll take a look at the one on the left right over here. Oh, didn't change the color. Let's change that back. So this one right over here, and that piece, again, we're going to use that -1 as our slope. So -1, and then we have our x minus x1, so x minus -3, so that means plus 3. And then we have our y1, which is 0. And then this is everything to the left. If we take a look at our graph, it's starting at that -3 and going to the left of it. So x is less than or equal to -3. And then we'll go ahead and take a look at that second piece on the right. So this piece right over here. And we're going to write out that equation. And this time the slope is a positive 1. And we have that same point. So x plus 3 plus 0. And this time it's everything to the right of 3. So our graph is everything to the right of 3. So x is greater than 3. All right, let's try one more for good measure. Let's take a look at this last one over here. Same thing. I'm going to write out the absolute value function. The more I write it, the better or the easier it is for me to memorize. So y is equal to a times the absolute value of x minus h, and then plus k, where a is our slope, hk is our shared point, also known as our vertex. So if I take a look at this particular graph, we have that shared point right over here, and that shared point is going to be located at -3, -1. And then we can take a look at our slopes. So this time our slopes aren't -1s and positive 1s. I'm going to pick two random points where I could read the ordered pair. So I have one over here and I have a 1 over here. And we can see that we're going down 2 and over 1. Since we're going down 2 and over 1, that means it's -2 over 1, which is -2. So there's our slope on the left. And then our slope on the right, again, pick two random points as long as you can read the ordered pairs. We go up 2 and over 1. So that means it's going to be +2 over 1, which is 2. So we can recognize that we have the same slope, except one's a positive and one's a negative. So plus or minus 2. That's a big clue that we have that absolute value. Again, we have that V shape. So we have that V shape right over here. And we have our arrows. And since we have a shared point, a slope that is plus or minus the same value, in this case 2, and a V-shape, we know we have that absolute value. All right, so let's go ahead and write it out in terms of a function. So f of x is equal to our slope. Well, again, our slope is going to be that plus or minus 2, but we're just going to write down 2. And then we have our absolute value signs. We have our x minus, and then our h in this case is -3, so minus a negative becomes a positive, so plus 3. And then we have our k, which is -1, so -1. Now we're going to leave it like this because we don't have any zeros to simplify, so we're just going to leave it like this. All right, and then our piecewise function. So our piecewise function, again, very similar. We're going to go ahead and take a look at two pieces. We'll take a look at the one on the left. And if we take a look at the one on the left, that's the one where we have that slope of -2. So I'm going to go ahead and use the -2 as my slope. And then we have our parentheses, x minus x1. Well, remember, x1 is our -3, so plus 3. And then our y1 is our -1, so -1. So again, it looks very similar to our absolute value function. Now let's take a look at where our graph is. Well, remember, we're looking at it in terms of x. So it's everything to the left of that -3. So that means x is less than or equal to -3. And then we go ahead and do the other side, the other piece. If we take a look at that other piece right over here, we can see that our slope is the +2. So we're going to put in that +2, and then we have our x plus 3 minus 1, because we have that shared point, and now it's everything to the right of that -3. Now, since I included the -3 in the previous one, I'm not going to include it in this one. So that's how you go ahead and write out your absolute value functions and your piecewise functions. Notice they're very similar. In terms of the piecewise function, you need both the positive and the negative slope, and then we have our shared point. In this case, it was -3, -1. However, in the absolute value function, if they have that slope that is similar, it's just one's positive, one's a negative, we're just going to write out the absolute value of that slope, which is just 2 in this case, and then we'll go ahead and put in our x1 and our y1 in place of our h and our k. All right, I hope this helped out. If you have any questions, go ahead and leave a comment, and don't forget to like and subscribe. All right, good luck, enjoy, and have fun.